Welcome, everyone. My name is Camille Fournier. I am the head of engineering at a company called Rent the Runway. I'm also a ZooKeeper person of note, perhaps you might say. And this talk is called, ZooKeeper for the Skeptical Architect. The goal of this talk is really to describe ZooKeeper at a high level and talk about how you might think about when to use ZooKeeper, when to use a product like ZooKeeper in your organization, what kinds of problems it's really good for solving, and when you might consider using something else, something that, something simpler, something different to solve these problems. So, I like to start this talk by saying that actually ZooKeeper is kind of everywhere right now. So how many of you have ZooKeeper running somewhere in your organization? Okay, so like at least a good half of the audience. Even if you're not running it yourself, it's running somewhere at your company. And even if you personally aren't running it or your company isn't running it, you may be running something else, right? Google has their own version of ZooKeeper called Chubby. Well, Chubby is really the original. ZooKeeper is the imitation there. But there's a bunch of new things out there. etcd is one that people are starting to experiment with. So the ZooKeeper type products, and ZooKeeper especially, it's really all over the place, right? You're running Hadoop, you're using ZooKeeper. You're running Storm or Kafka, you're using ZooKeeper. Netflix uses ZooKeeper. And ZooKeeper is very well established, not only in the startup community, but also in the enterprise. And I think, when I was preparing this talk, I actually saw a link to an interview with Leslie Lamport, who hopefully you kind of know who that is. You've heard of that person, invented Paxos, won the Turing Award this year. And he had this great quote in that I thought was perfect, right? You look inside of Bing, which I guess is a thing now, or Google or Amazon, where they've got rooms full of computers, they're probably running an instance of Paxos, and that's very, very true. Because ZooKeeper is, in my mind, really a fundamental sort of element of the distributed operating system. If you think of, what are the fundamental things in an operating system? Well, every operating system probably you need a file system as part of that. You need this, that, and the other. I would argue that ZooKeeper is a fundamental, ZooKeeper or systems like ZooKeeper are a fundamental part of most of the distributed operating system. And so that's why you see it sort of everywhere. However, ZooKeeper isn't actually everywhere. And in fact, there are some big notable companies and products out there that are big distributed systems that are not using ZooKeeper. For example, React, Cassandra, MongoDB. These are big commercial distributed data stores. They do not use ZooKeeper. And a lot of people, I think, see this and have asked this question, maybe not a lot, but certainly some people have seen this and asked the question, so, these systems, they have some needs for consensus type stuff, but they're definitely not using ZooKeeper. Does that mean that because these companies have really smart distributed systems engineers working for them, that actually they know better than I do and ZooKeeper is a bad thing and I should stay away from it? And I think the answer is, well, maybe. If you are trying to build your own commercial distributed system that you're trying to sell to people, you may want to avoid using ZooKeeper. The reason that these systems do not actually depend on ZooKeeper, I would say by and large, reason number one with a bullet is they're trying to make money. And how do you make money in the crowded world of distributed data stores, distributed systems? You make money via simpler operational complexity, right? You don't get people in the door when there's a crowded field of competitors if you have a lot of operational complexity. And even though ZooKeeper isn't that operationally complex, the fact of the matter is it's another system you have to think about either integrating with your own code or supporting yourselves, having your customers say, oh yes, actually, you also have to configure this separate ZooKeeper cluster in addition to all the other machines that you're going to be running for my distributed data store. And frankly, that's a lot of overhead to add when you're trying to sell a product. Additionally, you may not want to be depending on a big third-party, system and library that moves at its own pace. And you probably don't need every feature. ZooKeeper is actually a fairly richly featured system. And a lot of these projects, even though they do need a little bit of consensus for various operations, maybe as they start up, they kind of want to know who's around, or in certain types of partition situations, they don't want consensus at the sort of strictest and highest level all the time, and they don't necessarily want every single feature of a system like ZooKeeper. So it makes sense for these distributed data stores not to be dependent on ZooKeeper. That doesn't mean it's not a system that you should use. The last point I will make is the point of availability. ZooKeeper favors consistency. If you're familiar with the CAP protocol, right? Consistency, availability, partition tolerance. You can't actually get away from partition tolerance. You have to have that. That's a part of a distributed system, so you can pick either consistency or availability. Most of these systems are favoring availability, right? React, Cassandra, they want to be able to let you configure it so that all of the other nodes except for one can be failing, and you can still be acting with that node and doing things. And okay, maybe the state is a little inconsistent when the rest of the system comes back up, and you, the person using it, have to be comfortable with that trade-off, but you'd rather have that high availability. ZooKeeper doesn't work that way. You cannot continue to operate against your ZooKeeper cluster and be writing things to it if a majority of nodes has failed, right? You have to have a majority of the quorum members of a ZooKeeper cluster to be available to operate. So if you want to build a system that really favors availability, that doesn't mean you can't use ZooKeeper, but it does mean that you have to be very judicious as to where you put it and how you use it, because ZooKeeper can easily cause your system that you would prefer to be highly available to be much less highly available because of its dependencies there. There is another company that does not use ZooKeeper, and that is my own company, Rent the Runway. And part of the reason that I wrote this talk is because I thought, it was interesting that I have been at Rent the Runway now for 2.5 years and have yet to put ZooKeeper into production. We're finally starting to look at it, but I haven't done it yet. And I thought that it would be useful for people to hear about, hey, I'm a person that knows a lot about this product. I actually really like it. I still support it through, the community. But I'm not using it right now in production because it doesn't meet my criteria for need yet. And so how do I think about putting something like ZooKeeper in production? How should you think about, okay, I have some problems. I think ZooKeeper might be a solution to the problems that I have. And so I think there's really 3 areas that you can use to evaluate ZooKeeper to determine whether or not it's a good fit for the problem that you're trying to solve with it. The first area is where is it running? What does my production environment look like? How many machines do I have? What's the specs? So Lamport again, right? I think if you were in Hodge's talk earlier, he just mentioned this quote: distributed system is one in which the failure of a computer you didn't know existed can render your own unusable. Now, technically, a web server and a database is a distributed system. It's a distributed system from the point of the client, perhaps, from the point of the user of your web server. They don't know that there's a network connection in there that might cause the web server to fail. From you, the developer's point of view, though, yes, it's a distributed system, but it's not really like the kind of distributed system that you need a ZooKeeper for, right? You know all the pieces. You can keep the operational complexity of that distributed system in your own head, right? You could just have a piece of paper with oh, here's the addresses for my web servers, there's 3 of them, and my database, dbo1.prod, right? Great, okay, done and done. Not a very operationally complex environment, technically a distributed system, probably doesn't need something like ZooKeeper. ZooKeeper is useful in an environment where you have a need to do a lot of complex operational support. So if you are in a small startup where you have one ops guy who sleeps with a pager by their bed, right? And you have a bunch of DevOps that maybe know how to restart a server, and they can debug a few things, but not full-fledged operations folks. You may not be in the right environment to be running something like ZooKeeper unless it's a truly critical piece of the product that you're trying to build, because ZooKeeper does require a bit of operational support. On the other hand, if you are in an environment where you've got a fleet of just systems engineers who are doing really nothing but making sure all the machines that you've got racked are racked right, that the network's all going well, that the performance is right, that all of these various things that happen on that sort of low-level operational side are running, you might be in an environment where ZooKeeper can be very, very useful, because ZooKeeper can help you with sort of the understanding of that environment, especially from a development point of view. If you're in an environment where you're rapidly growing, or you're racking hardware faster than you can keep track of how much hardware you have, and this doesn't happen often, but it certainly happens, right? I've read blog posts from various companies like Spotify where they've talked about, yeah, we're just racking new servers all the time to keep up with the growth of our product. If you are in that kind of environment, ZooKeeper may be very useful for you. Even if you're not in that kind of environment, if you're in the kind of environment where you experience a lot of very dynamic changes in the operational footprint of your software, so you're cloud scaling and cloud bursting out, you have 5 servers running most of the time, but occasionally you have 100, and you want to know what's running, when it's running, where. ZooKeeper is a great product to start to use because it can really help you with building systems that can be that can use that rapidly scaling, rapidly changing, rapidly growing environment without having to constantly restart, reconfigure themselves, go out and rediscover everything, right? ZooKeeper can be the piece, one of the pieces of infrastructure that you use to manage this rapidly growing, very dynamic environment. Where also, by the way, things are rapidly failing. Anytime you've got an environment where you've got a number of servers out there, inevitably something is failing all the time. And you want to be able to build robust systems that can tolerate that failure and not all completely fall down themselves. ZooKeeper can help you do that. So this is the environment where most people who are thinking about using ZooKeeper, this is the environment that they're working in. And this is part of the reason that you see the adoption of ZooKeeper so widely in the last 5 years, because many of us were running those one web server to one database, or maybe 5 web servers to one database environments for a long time. LAMP stack, right? We all remember that. Well, all of a sudden, we've got way more customers or way more data, and we want to be just being able to deal with a whole bunch more computers because it's just a lot cheaper to horizontally scale things than it is to vertically scale things. Right? We don't want to buy supercomputers. I want to buy like 10 cheap things, or even better, I want to go into Amazon, or I want to go into my cloud provider and just requisition a few instances to do something. So in the last 5 years, we've gone from an environment where very few people were working at this kind of scale, dynamicism, rapid growth, to where almost everyone is working in this world. And that's why we've seen a lot of adoption of this. So question number 2 that I like to ask, maybe my environment is suitable for this, maybe it's not. Another question you can ask is, okay, so what is ZooKeeper going to be doing for me? What am I looking at ZooKeeper to actually do? And there are really 2 fundamental use cases where, if this is what you're looking to do, ZooKeeper is a very good match, right? So the first one, distributed locking. If you are using anything else to do distributed locking, it is probably not a great idea. That doesn't mean it won't work for you, but it's going to fail. It's probably not going to be right. Frankly, you need a consistent system to do a reliable distributed lock, and pretty much everything you have is not consistent. Most systems are just not going to give you that guarantee, right? I've done distributed locking myself with files. Probably all done that, right? In your lock file, you rely on the process to clean it up. If the process doesn't clean it up, you call someone on the phone, you say, hey, listen, buddy, can you delete that lock file for me so that the other server can start up? It's fine, right? That's okay, okay? It's not the worst thing in the world, but that's not a really reliable distributed lock. And when you care about just reliable distributed locking, you want something like ZooKeeper. A great example from the enterprise, and in fact, the reason that I'm starting to look into ZooKeeper myself in my own environment is that we actually use messaging, and we rely on the order of messages. We're using RabbitMQ to stream in data to us, and we care about processing those messages in order. So I cannot have multiple machines reading from the same, whatever it's channel, whatever the AMQP term is, queue, if you're in JMS, right? I cannot have multiple machines reading from that same queue at once because they may process those messages out of order. And if I'm talking about a lovely dress like the one I'm wearing, coming into our warehouse, getting scanned into receiving, then scanned into cleaning, if it gets scanned into receiving and scanned into cleaning, and for whatever reason those messages are processed out of order, my systems get very confused, and they think where the dress is in the wrong place. It's actually being cleaned, but they think it's being waiting to be cleaned, and so a bunch of processes are not going to do the right thing. That ordering is important to what I'm doing. However, if the machine that owns all this processing that's taking these messages in and is actually acting on them crashes for whatever reason, the hardware goes bad, there's a bug, who cares, who knows, whatever, I don't want to have a developer or an ops person have to push a button and fail it over to another machine. Why not? Because I have barely enough warehouse capacity to get through a peak day as it is. If I lose 5 minutes waiting for somebody to run to a computer and do some stuff, that's a bad situation. And this is certainly something that happened, I saw a lot when I worked in finance, right? Very common. Again, you've got this processing going. You really cannot afford to lose the amount of time it takes for a human to recognize a failure and fail something over. So you can use a distributed lock to actually do that high availability, singleton failover very well. And that's a great use case for ZooKeeper. The other use case is what I'll call service management, sort of an umbrella of cases. So a lot of people think of ZooKeeper, a very, very, very common use case is for distributed dynamic discovery, right? DNS replacement, you might say. In fact, Chubby, the Google equivalent, was largely written for these two use cases, a big one being that Google could not make DNS scale for them when they were getting to the sort of certain size, right? Various constraints of DNS simply made it so that it just wouldn't scale for the amount of machines that they had. And in fact, this whole dynamic discovery is a really, really useful thing that ZooKeeper can provide, right? You can say, hey, I want to know who's up right now, who's available, what machines are available, doing what actions, so that I know who to talk to. So this is not just dynamic discovery, also it's just general service registry. You can use it for configuration management, right? You can store dynamic configuration inside of ZooKeeper, and that will actually let people know when configuration changes and they can automatically update themselves. You can also use it for monitoring to some extent, right? ZooKeeper is not a be-all, end-all monitoring situation. There are a lot of other really great monitoring solutions out there, but ZooKeeper can be a good part of a monitoring package, especially if you're building a system where you just need to know a few limited things about your environment. However, I will say that service management is a problem that has been around for a lot longer than ZooKeeper. Even when you're in a very simple SOA environment, where maybe you have a web server and it's talking to a couple of services and they're talking to a database, there's always been this sort of need to manage those services in some way. And there are a lot of alternatives for doing this. So I actually have a big SOA environment, and again, as I said, I'm not using ZooKeeper. So what am I using? I'm actually just using a very simple load balancer. Load balancers work really well if you are in certain circumstances. Number one, if you don't have long-lived connections, if you just do a connection per request type model, a load balancer across a perfectly horizontally scalable set of services works perfectly fine. You can take your load balancer, you can drain services out of it to upgrade them and update them. No big deal. If you only have one version of your services running in production at any time, that's great. Now that's a bunch of ifs, but it's actually not impossible to be in that kind of environment. So a load balancer is a perfectly reasonable use case to do your service management, so long as you're in a very simple environment. DNS. So I mentioned that Google wrote Chubby to get away from DNS, but DNS is actually pretty useful. It's a very, very, very well-tested, distributed, read-optimized data store. And in fact, Spotify, for a very long time, they wrote a blog post called "In Defense of, old software," or something along those lines. I can't remember the exact name, but it was all about how they use sort of standard stodgy software to get the job done before going to something newer, because they trust that sort of old software is going to get it done. It's very reliable. It's out there. And they talked about how they use DNS to do a lot of their service management for a long time. So you can do this, right? You can use DNS and store, various information about all the servers that are out there on a DNS server. That works really well. You can also use it for minor configuration information. It doesn't scale that well because all of a sudden, every time you add new machines, you're having to update the data in your DNS server. That's a little weird. And DNS really only tells you about what could be out there, not what actually is out there. So it has some downsides, but it's perfectly usable. If you're interested in it, I recommend you look up that blog post. Finally, you can use a database for some of this stuff, right? Look, a lot of it's just about tell me what information is, right? Maybe you want to store some configuration information. You can store it in a database and people can just read it out of there instead of going to some other distributed system. That works, it works fine. I think some of the problems with using a database are that, well, now you've added a bunch of load onto your database, which you may or may not want to do. Standard databases are, well, that's a single point of failure, right? If you're talking about your normal MySQL or whatever, it's probably a relatively single point of failure that you may not want to be messing with. If you're talking about a distributed data store, then you have the problem of, look, most of those distributed data stores are not written to be consistent. Maybe for your service management you do not care, but maybe you do, right? And you certainly don't want to have information that's very, very stale that you're reading. For example, if you're using it for monitoring, you don't want to see a service up message and then the service down message when in fact the ordering was service down and then service up. You actually care about that. So your databases can be helpful. It's a perfectly valid alternative, but it's certainly not the most ideal case. So finally, there is this sort of fundamental question of what are you really using about ZooKeeper? Why are you using it? What's the key aspects? Because like I said earlier, ZooKeeper is a very, has a fully featured system. It has a lot of different things that it can do. And this actually causes some confusion because it has a lot of things it can do doesn't mean it has a lot of things that you should do with it. So I would say that the really three key, you could call them primitives or whatever, that I look at when I'm thinking about writing something in ZooKeeper is, am I relying on one or more of these really to solve my problem correctly? Because if I'm not, I may not be using ZooKeeper for the thing that it's really meant for. So number one with the bullet is consistency, right? If you are relying on, atomicity, that ability to write something and, read the value that you wrote reliably, if you're relying on the ability to, make sure that if the system says that it got a value that you wrote, it's not going to lose that value on you. It's committed it. It's in a majority of nodes. It's out there, right? If you are relying on that consistency property that you cannot get in a great number of these otherwise distributed systems because they are not favoring consistency, they are favoring availability. If you really, really need consistency, distributed locking, again, you really need consistency. Great, you're probably using ZooKeeper for the right thing. The other two primitives that ZooKeeper provides that I think are very interesting and useful and tend to indicate a good use case are ephemeral nodes and watches. So ephemeral nodes are nodes that are session aware. So when you connect to the ZooKeeper, and I'm not going to go over the details of how ZooKeeper works in this talk, but very, very briefly, it's a tree-like structure of nodes, can have children, can have data. You can create nodes that are called ephemeral, which means that they are associated with the session that created them and will go away automatically when that session dies for whatever reason. So if you close your client, it automatically cleans them up. But also, if for whatever reason your machine dies, crashes, gets cut off of the network, the nodes will go away. And this is incredibly useful, again, when you're doing things like creating distributed locks so that you don't have to write a bunch of cleanup logic yourself to say, oh, actually, this machine grabbed that lock, but nobody bothered to clean it up and it crashed, so nobody's been able to move forward even though, in fact, the holder of the lock is dead. Ephemeral nodes take that away from you. Also in the distributed discovery case, right? You can actually know who's available and who's not because you're writing ephemeral nodes that say, hey, I'm out there, I'm doing purpose X, Y, or Z, you know I'm here. The minute that that node goes away for whatever reason, and the nodes will go away because again, the point of ZooKeeper is that you're using it in an environment that's fairly large, so crashes and bugs and issues are probably going to happen. Those ephemeral nodes go away, and that's a very powerful feature. The flip side of that is watches. Watches let you know about data changes, data updates. They can tell you when nodes are created, when data inside of nodes is updated, without having to poll all the time to see changes. So it's not quite the same as a messaging bus where you're getting pushed information all the time, but it lets you register you are interested in state changes and lets you know when that state changes so that you can do some kind of an action. It's another very powerful primitive, very, very useful. Again, if you care about not having to poll something and that's actually important to you, use watches. And if you're using watches, probably you're doing something right with ZooKeeper. I added this slide to this talk because I was having some conversation, clearly with Kyle and Coda, around ZooKeeper and new things. And Henry Robinson, who's one of the ZooKeeper original authors, worked at Yahoo back in the day, is now at Cloudera, even says, look, ZooKeeper seems to have some identity problems, right? Is it for coordination? Is it a kind of key value store? Is it pub sub? And to these I will say, yes, definitely, kind of, please not, right? So yes, it's definitely for coordination. ZooKeeper was written for coordination. Coordination is a great use of ZooKeeper. ZooKeeper can be a key value store. It is a key value store. Fundamentally, the way that it stores data is key value based, which is useful and powerful. But what you want to be storing there is metadata or pointers to data, not data itself. ZooKeeper is not your distributed cache. You could probably use it for that. I know there are people doing that. You can do it. I mean, look, we can all do lots of crazy things. We're engineers. That's what we do. But if it causes you issues, you can cry to us on the mailing list, but we're not going to be very sympathetic because ZooKeeper is not really designed for that purpose, right? Key value, yes, key value is, because key value is powerful, key value doesn't restrict, what you guys are going to be doing with this server, but really it's not intended to store a ton of data. In fact, one thing to note about ZooKeeper is it keeps all of its state in memory at all times. It does this because if it has to garbage collect, you're done, right? All of a sudden heartbeats aren't happening. If you're familiar with Java, you know that if you do a full garbage collection, everything stops. That's why they call it stop the world. And if you're relying on heartbeats, those heartbeats may not happen, and all of a sudden your performance guarantees are just dropped on the floor, and it's a very bad situation. So ZooKeeper is meant and designed to be kept entirely in memory, never garbage collect, so that it can meet its performance requirements. That means you really have to be gentle with what you're putting in it because you don't want to ever push it to that limit. And finally, PubSub, people use it for that. But that's not the point of ZooKeeper, right? If you want to do messaging, there are messaging systems out there. Use RabbitMQ, use Kafka if you want to do really broad distributed messaging. There's a whole bunch of options out there for PubSub messaging. That is not the point of this system, right? It's not a PubSub messaging system just because it can be done doesn't mean you should. So those are really the three major ways that I like to think about a problem when I'm presented with it. Say, should I use ZooKeeper or should I not? And I think about that because I care about operational overhead, right? I am currently running a small team, but even if I wasn't running a small team, I want to be very conservative. I'm a skeptical architect when it comes to adding new pieces of functionality to my environment, right? If it comes to adding a new system, I want to be very skeptical, and I want to think very carefully about what am I doing, and am I really doing absolutely the right thing or not? So once I've answered those three questions, and maybe you've asked yourself those three questions and said, yes, I do want to put ZooKeeper into my environment, what are some of the challenges I should expect while doing this? And again, I'm not going to go into all of the details of ZooKeeper. One of the challenges is that ZooKeeper code, client-side code, is challenging. It's hard to write. And I could talk about that for a long time, but I'm not going to. Instead, I'm just going to say that you need to be aware that that's hard to write because this stuff is hard to reason about. And as a result, you can get the problem of clients run amok. So ZooKeeper is actually designed to be a shared centralized service, right? You should be able to run multiple different clients against ZooKeeper doing the same thing or different things, and it should be fine, right? You should be able to run Kafka and Storm and Hadoop against the same ZooKeeper cluster and be okay. And in fact, I know that there are people that do that in production. So in general, ZooKeeper should be shareable unless someone does the wrong thing. And like I said, writing client code is hard. So if all your data is stored in memory and you basically blow your stack and cause ZooKeeper to garbage collect, you have a lot of problems for every single person relying on that ZooKeeper. When I originally did my first large project with ZooKeeper, there was one group out there that was using Perl, and they needed a Perl client for the thing that we were doing. And we had provided clients to everyone else in all the other languages, but I didn't know Perl. My team didn't have any Perl. Frankly, I don't really like Perl, so I was like, fine, you know what? You guys write your Perl client. I trust you, a very smart team. And so they did, and all was fine until one day, alerts start going off, the cluster isn't responding, everything's going haywire, and we look at ourselves and we're like, oh my God, what the heck's happening? And we trace it down to, oh, one of those guys, machines over there that wrote that Perl client is doing something. What's going on? And we take a look and we ask them to sort of open up their code, and we see, oh yeah, they just had some bug that created a tight while loop of just updating, and that was it. It was done. So a misbehaving client, unfortunately, can cause a lot of problems for this if you run it as a centralized service. That's of course true for any kind of centralized service, worth pointing out for ZooKeeper. So you have a few options to deal with this. You can simply not share your ZooKeepers and have individual ZooKeeper clusters for, per group. I personally think that's a fine decision, but it's a lot of overhead and it's kind of unnecessary. The best way I think that most people do this is actually through code review. So most companies, I think Facebook does this, I know that Google does this with instances using Chubby. They actually require a code review by the people that support the ZooKeeper functionality, right? Because those are the people that are really the experts in how you should be interacting with these systems, and they're the ones that are going to get paged when the system goes down and causes mass havoc across a cluster. So they want to have the last word in, are you using the system correctly or not? The other thing that you can do, which is what I actually did, again, for everyone except for those Perl guys, was to provide wrappers. So if you know exactly what it is that you want people using ZooKeeper for, if you're writing a distributed dynamic discovery service, which is what I was doing with it, you can write a wrapper that really encases all that functionality and just provides a very simple API to all the clients. That actually works very, very well, and it's probably the right thing to do anyway, because you don't really want everyone to have to think about how to really work with ZooKeeper, or even how to work with a client like Curator, which is a better abstraction. So this is one of the big challenges that you will get if you start running ZooKeeper as a shared service, and just something to be aware of. The other thing, and this is really specific to this enterprise audience, is that ZooKeeper has a very sort of strict odd numbers rule. Because of its consistency guarantees, because it uses a voting mechanism to determine whether things can happen or not, you always need to have a majority of cluster members available, which means that in practice you're always running an odd number of servers. So you're running 3 servers so that you can lose 1. You're running 5 servers so that you use 2. Right? 3 or 5 is the very much common. If you want to scale beyond that, we recommend you use something called an observer, which is just a read-only server. Unfortunately, this also applies to data centers. So if you want to run ZooKeeper such that you can lose a data center and your ZooKeeper quorum won't go away, you need to run it across 3 data centers. And that is unfortunate, but it is what it is. I think when I was running ZooKeeper in the enterprise, unfortunately, we had 2 data centers everywhere, which is awesome, but does not work for an actual distributed system like this. And I really was kind of upset about this fact, because it meant that I had to think about, well, I have to architect this so that it does not go down if we lose a data center. Because again, if you only have 2 data centers and 3 nodes, you have to put 2 of them in one of them. And if that data center dies, you've only got 1 ZooKeeper left, and that guy's not going to do anything for you. So you have to have a 3rd data center to put a tiebreaker node. In practice, the way that I recommend doing this, and I'm happy to talk at more length with anyone who wants to hear about this, but is to actually put a tiebreaker node in a 3rd data center. And if your 3rd data center happens to be far away from your first 2, just make sure that that node is never the leader of the quorum, and make sure that no clients ever talk to it. Because the only time that having a 3rd node or a 5th node or whatever, a tiebreaker node in a distant data center actually causes you problems is if that node is actually in the main voting path. So if you have, let's say, 3 nodes across 3 data centers, 2 of which are close together and 1 is far apart, as long as these 2 are up and operational, they will always vote much faster with each other and commit changes very quickly. And as long as all the clients are talking to them, it's fine. It doesn't have to be forwarded anywhere, right? If you have, however, this 3rd node becoming the leader, all of the data for any updates is getting forwarded to the 3rd node, which is going out to the other 2, coming back to the 3rd, and then going finally back out. Not good, right? A lot of cross LAN or WAN traffic there. So just, sort of a heads up and an unfortunate fact of this kind of system, but I think probably an unfortunate fact of any of these kinds of systems is that, you've rule of 3s, odd numbers rule this environment. And that's just, when you need a majority, you need a majority. So the last thing I will say is that if you are not careful and you do not think about how you use it, ZooKeeper can own your availability. And as I've said a few times in this talk, ZooKeeper is not designed to be a high availability from the CAP theorem perspective system. It is highly available, meaning that you can lose a node and it will still run, but you cannot lose a majority and still have the system run. It will not degrade down and down and down until it's still functioning even though there's only 1 node running. It doesn't work that way. So if you put ZooKeeper in the critical path of your application and ZooKeeper dies, your application is dead in the water. So you need to think about how you're doing it, how you're using it, because it may very well be that ZooKeeper is a nice to have. It's providing a nice to have type of functionality that you can continue to operate without, right? You want to do that nice degrading, partial failure mode where it's like, well, I have a cache of the thing that ZooKeeper was telling me about. And so that cache may be kind of stale, but I can still operate with that data as it stands right now, at least for a little while hopefully, whoever's getting paged right now is running and screaming and tearing their hair out and fixing this as fast as possible so that I can get back in the game and up to full speed. That's just, a very important important thing to consider, which I think sometimes people forget about. So last but not least, I wanted to mention some of the new alternatives because this space has become really just very, very popular in the last year. I think largely due to the Raft algorithm, which you may or may not have heard about. It's a new, simplified consensus algorithm. Very cool, very, very popular, and it's sort of really spurned this interest in distributed consensus and distributed consensus systems, and a bunch of people are now trying to build their own, which is probably for the best. Some of these alternatives are listed here. etcd is one. Console is one that just came out. Surf is not quite the same thing. It can be used to do some of this. It's more of a communication protocol that you can build things like this on top of. There's probably others that I'm forgetting about. To the enterprise audience, I do not recommend using any of these yet. That's not to diss them. That's not to say they're bad systems or they're not going to get there, that they are not there yet. These are all very, very new processes, new projects. I mean, the Raft algorithm is like, that paper came out like a year ago. So people are very excited about it, but there is a lot more to building a, successful, stable, distributed consensus system than simply implementing an algorithm. Although, for a long time, that was the biggest part of it, right? Because Paxos and Zab are just so complicated. You're actually, if you're interested in any of these, I would recommend going to Kyle Kingsbury's talk tomorrow, where he is going to Jepson the crap out of these, and show off some of their strengths and some of their weaknesses. ZooKeeper is an old project. It is crufty. There are things about it that we wish were better. It's written like Java 4 style. They don't even. Not everyone on the project even really understands Java util concurrent. That's like how old this project is. But it's had a long time to bake. It's had a long time to get to the place where it is, where bugs are relatively rare. They come up mostly when people are really, really, really pushing the boundaries of the project or using some of the functionality that is very rarely used, right? I found some bugs a couple of years ago in some of the auth logic in Java. Very easy to fix, right? Occasionally people will find bugs when they're really, really pushing the edges of the functionality. We have a new release coming out very soon, 3.5, which will have dynamic reconfig, so you can actually dynamically reconfigure your ZooKeeper cluster itself. I have no doubt that will have bugs in the first few releases, but it's a very exciting feature that I'm excited to see us releasing. And so, if you are interested in taking this and using something very stable, stodgy, boring but reliable, use one of the 3.4 releases. You're probably going to be fine. Let 3.5 bake a little while. But I think that, right now, even though there are some new alternatives coming out, and they're great, and I'm excited to see where all these projects go, ZooKeeper is probably the most reliable option out there for the time being. So that is really all I have. I forgot to say this at the beginning of the talk, but my Twitter handle is Camille. Please feel free, if you don't get a chance, to ask me a question now. If you have any feedback or questions, that's actually the fastest way to get my attention these days, because I have probably over 10,000 unread messages in my inbox, maybe 100,000, I don't know, it's ridiculous. I just don't read email, or not often. But if you want to try email, camille@apache.org. will get to me. I can't promise that I'll read it, but I will try. If you are interested in that whole global high availability ZooKeeper, I have a blog post. My blog is wildfiles.blogspot.com, and if you just go there, you'll see it because it's one of the most read posts on there. That Spotify DNS thing I was mentioning is at that link, labspotify.com/tag/ZooKeeper. And I am happy to take any questions you all have. Yes.
One of the prereqs you had was ops support. I was wondering if you could quantify or qualify that a little bit more.
Yeah.
Because I'm just a DevOps guy.
Yeah.
So.
I tease about DevOps, but I think that ZooKeeper has a little bit of a steep learning curve for setting it up initially. It's not that hard, but it's you've got to read through the documentation and you sort of configure a few files, and get comfortable with it, right? We have recommendations where we recommend you have separate disks for the transaction logs and the snapshots, and we recommend you don't run this in a VM, although actually you're probably fine. Unless you're trying to really get to the max performance ZooKeeper, you're probably fine if you run it in a VM. And it's just not that big a deal unless you're really trying to push as much through as you possibly can. So I would say that from an ops support perspective, it's more like, adding anything new requires you got to set up your monitoring. You got to think about where it's going to be. You don't want all 3 of your ZooKeepers running on the same physical box if you're running them on VMs, right? You have to actually think about, all right, where is it being placed? Let's do a few load tests just to make sure we haven't drastically misconfigured something. You probably want someone that knows a little something about Java. Is awesome if you have that person around, because if you hit any problems, a Java person will probably be able to solve them or detect them very, very quickly. Again, not necessary, but useful. Most of the work in ZooKeeper is just sort of setting it up and getting all the ducks in a row in the beginning, right? It's about the configuration, getting log rolling working, cleaning, making sure everything's cleaned up, making sure you're on the right boxes, getting all your alerting set up. Similar to any other, new system that you might put out. Yeah. Oh.
So you mentioned that ZooKeeper tries to never run GC in order to stay available. Does that mean that if it's running over a period of like months that the memory footprint just like steadily goes up and up and up?
So it's not never GC, right? It always is doing, young GC, right? Partial GC.
Gotcha.
The goal is to never have to do a full GC.
Okay.
Right, so never having to put so much unused, unreferenced stuff that you have to clean everything up and really do a full compaction.
So that's basically not usually a problem.
Not usually a problem, no. Again, unless you're really like churning through a lot of data.
And the other thing I wanted to ask is, when you deploy ZooKeeper, do you normally use dedicated servers for it, or is it lightweight enough that you can put it just on random other servers and not have to worry about it too much?
So I think it is recommended to put it on dedicated servers. Again, it depends on how much you're going to be using it for. If you're going to be using it to manage like 3 locks or 5 locks or something very lightweight, it probably doesn't matter. But if you might expand it and expand it and expand it to say, oh, I'm actually going to have 10,000 or 20,000 servers that are depending on this for distributed discovery or whatever, you want to have it on dedicated hardware. So we have best practices for setting it up. We recommend, again, separate disks for some of the various logs and transactions. But those are just guidelines. There are some great performance testing scripts out there that you can run against however you do your setup, just to give yourself a sense of, okay, this is kind of where the boundary of my particular setup is. I recommend definitely like running those if you have that question at all. Cliff?
Yeah, so one of the things that I've had trouble finding guidance on is, what's the practical limit on the number of watches per machine?
Oh, that's a really good question, and I don't know it off the top of my head, but I know that someone, unfortunately, it's in the, I want to say it's in the thousands to tens of thousands. Like you can do a lot of them, but you can't, there is definitely a tipping point. I think a lot of times with ZooKeeper, it's often not a steady degradation. It's often just you're done. Like you're fine and then you're done. It's a little bit like running out of file descriptors in a Java process, right? You're fine until you're done. And that's something that, if you're thinking about running ZooKeeper in an environment where you're gonna have a ton of connections, you need to think about how many file descriptors you've allocated to these processes. I think watches, in my understanding, is fairly similar. We've got some work. Facebook is actually using ZooKeeper, really like pounding the crap out of it. And they've got a bunch of patches, some of which we've put in, some of which we're working through, to just improve a lot of the scalability of these things. So I don't know if watches specifically, but a whole bunch of various aspects of ZooKeeper that could be more scalable. A lot of that work is coming out and coming in soon.
Cool.
All right. My question is about what kind of scalability problems did you see in your experience? Like how high did they push it? 1 million entries, 2 million, and how many nodes did they have in the cluster?
So I don't, off the top of my head, I'm not going to remember this, right? It depends on how big your machine is, how much memory you allocate to it, right? Again, it's all in memory. So if you want to put it on a machine with 16 gigs of RAM and allocate however many gigs to the process, you can do that. It will fail eventually. I can't tell you exactly the sort of number of nodes. It also depends on how much data you put in them. I think we have a configurable limit on the size of data in each ZooKeeper node. I unfortunately don't, off the top of my head, remember what it is. It's some number of kilobytes. Where we recommend you don't go above that in each node because, again, don't want to store data, want to store metadata, pointers to data, not actually data itself. But it depends on how much and how big it is, right? It's a math equation. How big is each node? I don't know off the top of my head, multiplied by how many bytes, by how much RAM you actually have by the GC and Java overhead. But you can go pretty big, right? I tested ZooKeeper with, I tested a quorum holding up to like 30,000 connections per, quorum member, and it's fine. It falls on the ground when you have more connections than you have sockets configured onto your machine. Not surprising, Java falls onto the ground when you do that. But I was actually able to have it running and working fine up until that limit.
We're using ZooKeeper for distributed configuration management. One of the things we've noticed is the performance of making calls to it tends to be very sensitive to network latency, such that when you're reading hundreds or thousands of nodes, it can take several seconds, even a minute, to read through everything. Do you have any suggestions or tips on any workarounds for it or new functionality in ZooKeeper to resolve that?
So your network is slow and you're reading a lot of data over the network and the ZooKeeper, and therefore the results are coming to you slowly? Is that the gist of it?
So if I want to read hundreds of nodes, is there a way to do that in one round trip instead of 1,000 round trips?
Yeah, so that's actually a great question. So we added a support for an operation called multi in the, I think 3.4, added an operation called multi. Now I don't know if this will work for hundreds of nodes, but multi allows you to batch up a series of operations, and all of those operations either succeed or fail as a group. So you can have several reads, reads, writes, executions, all basically in the same multi-transaction. So I don't know if it will help you exactly with, just a whole ton of reads, but it should help to some extent. You could probably use multi to help with that.
So multi will do it all in one network round trip?
Yeah.
Okay, great.
Yeah, it'll send it all off, and it'll all be processed and then returned back to you.
Okay. And just one other quick question. Is there any favorite web UIs to browse and manage the ZooKeeper?
So there's one that comes with, I think, just in the sort of our standard libraries. I forget exactly what it was called. It's in Python, which I used when I was running it, which works fine. I know that the Netflix exhibitor project is a ZooKeeper manager thing. I don't know exactly I have never used it. I know that it exists. So you could also check that out. But there is ZooKeeper comes with it. There is a simple web UI, I'm pretty sure it's in Python, that's somewhere in those packages that you can use to just browse and see what's in the tree structure.
Good. All right, thanks.
So I try to brush up on Paxos, and so I got a paper by Leslie Lamport, I think, like Paxos Made Simple, and it's simple for like the first 2 pages. And then he's got like a state machine that's like 144 states or something like that. Is there a resource where somebody can learn about it?
Well, so ZooKeeper is not Paxos. ZooKeeper is a protocol called ZAB, which is still pretty complicated, but it's not quite Paxos. I think there's a paper called Paxos Made Moderately Complicated, which is supposed to be better than Paxos Made Simple. If you are interested in distributed, consensus algorithms like this, and you actually have a use case for it, for example, you may consider just reading the Raft paper, which is the paper that came out that I was mentioning earlier. It is significantly more simple to understand. Unlike Paxos, especially Paxos, which doesn't even rely on TCP delivery guarantees, right? Paxos is so generic that you can use it over UDP, which means that it's just got all of these retry edges to its 140-some state machine, which just makes it significantly more complicated. ZAB is a little bit simpler. ZAB relies on TCP to guarantee certain elements of ordering. So ZAB is, you could read the ZAB paper and it may be somewhat easier to understand than Paxos because it takes one layer of that complexity out. But I would also recommend, if you're just interested in all of this, read the Raft paper if you're just interested in distributed consensus and kind of want to play around with it. There's a ton of interesting implementations of it out there, especially if you want to learn Go. Apparently every Go programmer in the world has implemented Raft, so if you haven't, you guys, you better get on it because that's a gold rush right there, Raft and Go. Anything else? Any other questions? Okay, I will be around until about 6:45 tonight, so if you have other questions, you can feel free to corner me before I leave, or again, I recommend tweeting me, especially if you've got like, oh, I'd really like to see if we can get this patch approved. It actually does work. I actually do look at those patches when people tweet them at me because it happens very rarely, so, but by all means, please feel free to do that. Thank you all so much for coming. I appreciate your attention. Have a great day.